Phishing. The attacker builds a fake login page that looks identical to a legitimate site and tricks the user into entering their credentials directly. No cracking required. The password arrives in plain text the moment it's typed. Phishing is the most common credential theft method by volume, responsible for the majority of account compromises worldwide. The fake page can be delivered through email, SMS, a search result, or a social media link, and modern versions are sophisticated enough to capture two-factor authentication codes in real time before the victim realizes anything went wrong. Social engineering. Instead of attacking a system, the attacker attacks the person. A phone call from IT support asking for credentials to resolve an urgent issue. An email from the CEO requesting a password reset confirmation. A message posing as a colleague needing access to a shared account. Social engineering requires no technical skill, only convincing communication, and a target who hasn't been trained to question unusual requests. It works because most security systems have no defense against a legitimate user willingly handing over their own credentials. Brute force. The attacker tries every possible combination of characters until one works. Against a 4-digit PIN, that's 10,000 attempts. Against an 8-character password using letters, numbers, and symbols, it's over 6 quadrillion. Modern GPUs can attempt billions of combinations per second, which means short passwords fall in seconds. Length is the only real defense. Every additional character multiplies the search space exponentially. Dictionary attack. Instead of trying every combination, the attacker works from a list, hundreds of millions of real passwords collected from previous breaches and compiled into a single file. If your password is a word, a name, a date, or anything a human would naturally choose, it's almost certainly on that list. The list doesn't just contain dictionary words, it includes common substitutions like @ for A, 3 for E, and exclamation marks at the end, because attackers know that's how people try to make weak passwords feel strong. Credential stuffing. When a website gets breached, the leaked username and password pairs don't disappear. They get sold, shared, and fed into automated tools that test them across hundreds of other sites. If you use the same password on the breached site as you did on your bank or your email, both are now compromised from a single leak you had no control over. Automated tools can test millions of credential pairs per hour. The breach doesn't have to be yours for your other accounts to fall. Rainbow table attack. A rainbow table is a pre-computed database of passwords and their corresponding hashes. Rather than cracking a hash through trial and error, the attacker simply looks it up in the table and reads the plain text directly. Without a salt, a random string added to each password before hashing, an entire database of passwords can be cracked in seconds. A properly salted hash makes every stored hash unique, which renders the lookup table useless regardless of its size. Password spraying, brute force hammers one account with thousands of guesses. Password spraying does the opposite. It takes one common password and tries it across thousands of different accounts. Most systems lock an account after a small number of failed attempts, which makes brute force easy to detect and block. Password spraying stays under that threshold on every account simultaneously, making it much harder to catch. The passwords used are always the most common ones. Spring 2025, Welcome 1, Company 123, because in any large organization enough people will be using them. Keylogging. A keylogger records every keystroke on an infected device and sends it to the attacker in real time. It doesn't matter how long or complex your password is. If it's being captured as you type it, the attacker receives it in plain text. Keyloggers are typically delivered through malware and run silently in the background, often undetected for months. They capture passwords, card numbers, messages, and everything else typed on the device, making a single infection far more damaging than any single account compromise. SIM swapping. The attacker contacts a mobile carrier and convinces them to transfer the target's phone number to a SIM card the attacker controls. Once they have the number, every SMS two-factor code meant for the target routes to the attacker instead. They then use forgot password flows to reset account credentials via SMS, bypassing the need to crack anything at all. The attack requires no malware and no technical infrastructure, only enough personal information to pass the carrier's identity verification, which is often available from previous data breaches or public social media profiles.